So yeah, first thing I'm going to do is get rid of that. I'm going to now create a delay line. I might as well use this object since I have it in line. I'm going to use something called tapin, which is just TAPIN with a tilde. And again, I want an argument on this tapin, and the argument for tapin is kind of the maximum delay, or the length of the delay line, if you like, in milliseconds. I'll give it 2000, which will be a delay of 2 seconds. As soon as I deselect and create the tapin, all of a sudden Max is complaining. My Max Windows says error. It's basically because this is what comes out of tapin is not actually a signal. What comes out of tapin is something that needs to be connected to something called tap out, which might seem unnecessarily complicated. So tap out tilde with an argument again of 2000. This argument will set the kind of initial delay time for the delay, and these connect together. You can connect, you can create multiple taps on a delay by just putting more numbers in here. We'll probably look at that later. Now if we have this ADC connected through a tap in to a tap out, and we connect that up to our EasyDAC, we should hear the effect of the delay, which is, because it's coming back in through my speakers as well, I'm getting a lot of copies of this, what I'm saying. Yeah, and if I left that on, you probably wouldn't be able to understand anything I said. Alright, let's go with changing the delay time. We'll notice if we scroll across the inlet of the tap out, it says signal float delay time in milliseconds. Awesome. Well, it doesn't actually need to be a float. We can just use a number box. Don't remember what the shortcut is for a number box again right now. I'm sure it's like, maybe it's an I. Oh yes, it is. So if you type I on your keyboard with the patch unlocked, that'll bring up a number box. I guess that's for int or something. Yeah. Alright, and now we can change this delay time by simply changing that delay there. And so now it's, changing in time here. What you'll notice is that when you change the delay time, assuming there's something kind of constant going on, assuming there's something kind of constant going through here, you'll hear it clicking when you change this time. That's because changing delay time in sort of discrete values, you're getting interruptions in the flow of the signal, so you are essentially creating discrepancies in time, which will always create clicks, or generally create clicks. Let's try just to make a different delay using exactly the same thing. Let's change this delay time with a signal and change it over time instead of changing it discretely like we are now. We'll use an object called line tilde. So if we make, again, N for new object, line with the tilde, and this object produces signal ramps. And what it needs, well, we could look at the help to again, Alt-click if you're on a PC, or Option-click if you're on a Mac, to bring up this help patch. It says here, a common way to generate a ramp is followed by a list and with a new value and a target time. Haven't talked about lists at all, but it says here you can have a list which will produce a value at over a target time. Simplest way to produce a list, I'm going to make a new object, and I'm going to make an object called pack, which is going to make our list. The first number I put in as an argument for pack doesn't matter because that's going to be replaced by what comes out of that integer box there, that number box. But the second argument will determine what time period it's going to change to that number according to the ramp, or by using a ramp produced by line tilde. So I'll take my number box, connect it to the left inlet of that pack, take the pack outlet and put it in the left inlet of the line tilde, take the line tilde and connect it to the tap out. And now when we turn on this EasyDAC when we change this over time, so we're changing the delay over time, what we'll notice, instead of getting the clicks that we were getting with the discrete changes, we're now getting pitch changes. Essentially because you're sort of reading the samples slower and faster depending on if you're going out in time, you're reading through the, you're reading samples slower, and if you're going back in time, you're reading samples faster, which produces again, there's all sorts of audio theory books, you can look that up in. That concludes this tutorial. Have fun. I'll see you soon with another one.